Now imagine one day I'm sitting in my backyard and I start to hear some crickets chirping. And I decide, well, wonder how often they're chirping. So I start counting how many times they chirp per minute. Well, I come out the next day, it was much colder, and I'm listening for those chirps and I don't hear them as often as I did on the warmer day. So I start to think, you know what, maybe there's a relationship between the two. Well, one of the aims of algebra is to provide us a symbolic context to understand those types of situations. And from that, we're able to develop something called a formula. So in this particular case, there is a relationship between the number of chirps per minute and the temperature outside. That particular model in this particular case can be modeled temperature in degrees Fahrenheit equals 0.3 N, where N is the number of chirps per minute, plus 40. So I can go out there and count and listen to the number of chirps per minute and know what the temperature is at that particular time. Or the other way, what's the temperature, and I can expect how many chirps I will be able to describe. So what happens? What can we do with that? Well, the whole idea is called mathematical modeling. So let's take an example. Say one time I counted 80 chirps per minute. So temperature equals 0.3 times 80 plus 40. 0.3 times 80 is 24 plus 40, so 64. So that tells me that I can expect when the temperature is 64 degrees that I could get a sense that I'm going to hear lots of chirping, 1 per second almost. I could also model higher temperatures and lower temperatures, lower numbers and higher numbers. Now, this is only one example of a formula and only one example of a mathematical model. We're going to see a whole bunch. And one of our goals as we progress to algebra is to be able to help work with those and learn from that and get a sense of what are we observing in the world around us in which we live.